will speak on, who will be presenting on complex reading comprehension through question decomposition. Thank you.
Yeah, so hello everyone. So my name is Xiao-Yu, and this work is actually presenting the complex reading comprehension through question decomposition. It's a work supervised by Yuan-Fang and Reza. So let's get started. Oops. So basically, I will go through this, 6 content. Firstly, the introduction. So is there anybody know about QA? Please. Okay, all right. So it's actually a very essential task in natural language processing. So its goal is kind of like, build a system that, answering the questions posed by human languages, to query specific information in context of either structured or unstructured format. So by structured, I mean, maybe there are some kind of knowledge bases or knowledge graphs. And by unstructured format, I mean, raw text. So what I'm talking about is that, you can just look at the right-hand side table here. So given this context, it's full of raw text. It's in natural language. So we can read it through, from the beginning to the end. And then we will have some questions like, SQ here I just mentioned is that the simple questions. So simple question 1 to 3. So why I call this simple question is because that we can directly grab the information or extract the information from the raw text. So given the context, we can, find answers from, directly from this paragraph, like the red ones, green ones, and blue tokens, right? So it's called simple questions. But in my work, I'm dealing with, mainly the machine reading comprehension. So given the context, we need to deal with the question, but I deal with more, most time the multi-hop reading comprehension task or multi-hop question answering. So this goal is kind of like similar when comparing with the QA task, but it's a little more complex. So it's kind of like to deliver a precise answer by conducting multi-step reasoning. So by multi-step reasoning, here is one example I listed downside. So the context is quite long, so I just shortened the context. The context you can just imagine is a description of the one American football game. It have 4 quarters. So I just list third quarter here. So there are some players, kick or achieve a field goal or touchdown passes. And the question may involve, like in this scenario, who calls the touchdown for the fewest yards? So it's quite different from the previous slide. We saw the, the simple questions. It cannot directly get from the context, but we need to, break it down into several steps to achieve our final goal. Like in this scenario, we have a question 1, question 2, question 3 to answer. Step by step, we can get our final goal, right? So this is this work's focus. It's actually the complex question answering or the multi-hop question answering or multi-hop reading comprehension task. And in this paper, we just want to propose a low-budget learning approach based on current, the transformer-based language models. So I guess the task is clear now, and now the second part, the really work. Maybe I shouldn't talk more about the really work, but I want to emphasize some, key points here. So the language models here, we use a lot of times, maybe you guys know a lot of it, So large scale language model like GPT-3, and now we have ChatGPT. are so effective on many, natural language processing tasks based on either fine tuning or few short learning or even zero short learning, right? And they achieve very good performance, but they have a lot of, parameters. Activity 3 have 100 billion parameters to be trained or to be fine tuned. So actually, it's quite, costly or expensive to train these models. And another shortage or disadvantage is that language models suffer a lot from the solving multiple questions and logical reasoning or numerical reasoning problems. I don't know if you remember the examples from Ed in previous talk, in his talk, brilliant talk, that he mentioned that the two digits addition or subtraction. So it's like the performance will, well, it's the performance is good, but 4 digits, 4 digits addition or subtraction, it will drops a lot, right? So the language models can learn, but it suffer a lot from this kind of numerical reasoning problems and also the logical reasoning problem I listed here. So actually we want to deal with that, but not with that large scale language models. We want to start from the smaller ones. Like we can train it, we can fine tune it based on the, the current benchmarks or data sets. So that is for the language model. And another aspect is for the multi-hop reasoning comprehension. So there is a lot of literature work on this part. I don't want to elaborate more, but there are some representative work like NumNet, which incorporates graph neural network to learn the relations between the numbers. And it deals with the numerical reasoning or multi-hop reasoning part effectively. And another part I want to introduce, because it's quite related to our work, is the question decomposition. There are a few works focusing on this composition part, but they are just used on maybe unsupervised learning way to learn to mapping the original question to sub-questions, and then they will answer each sub-questions to have the combination of the answer in the recomposition model, as I showed here. It's quite, complicated from my understanding to some extent. So we need to decompose and recompose. It's, error will propagate in each steps. So we cannot guarantee our intermediate answer are correct, right? So we propose that current issues is that we want to use the language models, the very effective language models, that's to solve the multi-hop question or the multi-hop reading comprehension task. And we also want to deal with the, current data scarcity problem that we don't have, so much annotations of the sub-questions or the decompositions. So in this work, we propose a novel learning approach to help language model better understand the multi-hop questions. Like we firstly automatically produce the sub-questions by a question decomposer. That is one, you can just imagine a language model. And another language model is responsible for the, the answer generation part, the reading comprehension component. So basically, our methodology, third part, is that it's very simple, but quite effective. So step one, we have a question decomposer. This part is like, we given a complex question, then we map it to several sub-questions. And then step two, we just concatenate them all, right? Because language model is like an end-to-end style that we can fine-tune it on specific data set. So we just concatenate the original question and sub-questions and the context and give it to another language model to produce the final answer. That's it. So intuitively, we can have both the decomposer and the reading comprehension component the same language model, right? And if we use the same language model, we call it unified model. So we you just imagine these two components share the the weights with each other, and we learn it jointly. And our training and inference is like we have two components, but we don't have any that much annotations for the sub questions. So we introduce two data sets, meaning here the drop data set is kind of like a reading comprehension data set, which have 77K training question answer pairs and nearly 10K for the testing. And another data set is break data set, which is a subset of the drop, but it has the do the annotations of the sub questions or decompositions of this kind of 7K training and 1K for testing. So they have this 7K and 1K have the ground truth, the sub questions we can utilize to train our decomposer. And this part is for the, we don't have any annotations for the rest of the, maybe 70K QA pairs. We don't have the annotations. So we use the HardEM algorithm to, to annotate them or to produce the pseudo labels for the sub questions. We don't have the annotation. We don't have the ground truth. So introducing the HardEM can also improve the, the performance of our model. We can see it detailed in our results. So the language backbone we use here, as I mentioned before, we just use the smaller language models here, T5 small, which only have 60 million parameters, and T5 base, more than maybe 200 million parameters, and bar base. And we also introduced GPT-3 here to do the zero-shot learning or the zero-shot prediction here to compare with our model, right? And the sub-question decomposition we are trained on the D2, as I mentioned, is like a break data set, which has the annotation of the sub-questions. And reading comprehension part, we also evaluated reading comprehension model on the D2 by F1 exam match scores follow previous works. And for the HardEM, because we need to annotate or to produce the pseudo labels, we use the whole data set as a weakly supervised data to train our model. So here is the result on the decomposition. We introduced two evaluation matrix, two types of evaluation matrix. Like one is intrinsic evaluation, is blue and root, to see how fluent or how the matching between the produced sub-questions and the ground truth ones. And as expected, using more training data, it can achieve a better performance on this matrix, blue and root. And another aspect is the extrinsic evaluation. So the final goal is that we need to use the sub-question and to produce the answer to the reading comprehension task, right? So we do the extrinsic evaluation here using EM and F1. So using different part of training data, we do produce the sub-questions from this language model and use that sub-question to the step 2, incorporate that question to give the answer. So we can observe. So also maybe a little not that expected, but with more training data, we can truly get better performance on the reading comprehension task. And that is just a bar-based language model. And we do the experiment also on the T5 small and T5 base, right? The same trends shows that we have better performance using a larger pre-trained language model, I mean, with more parameters. And the second aspect is that the reading comprehension task. So we have baselines like bar base and T5 base. This baseline is just end-to-end without any sub-questions as input. Just concatenate the question, the complex question and context, and to produce the final answer. And we have two variants, two types of variants. One is bar base and one is T5 base. And separate means we have two language models that doesn't share their weights for the decomposer and the reading comprehension component. So if you want to know sorry, the time is up. So if you want to know all the details, you can, I'm here all day and you can, discuss with me. So the final results shows that like our experiments or our two-step process can outperform the baseline by a large margin, and introduced by the Hardy-EM paradigm is quite efficient to achieve a better score. So that's it, the reference. Thank you.
Okay, if the next presenter could come up and start getting set up, and while you're doing that, we'll take some questions. So any questions to start? And if not, so one thing I was curious about, this division into two pieces naturally sort of matches with a lot of ideas in psychology in terms of thinking about decomposing problems and so on. At the moment, the model is doing two quite different tasks. And I wonder, you mentioned the challenges with the sort of arithmetic second step. What would you consider approaches where you sort of form a symbolic representation and then have a calculator do the second step? And so rather than the model having to understand language and calculation, sort of just explicitly say, okay, now that you've broken it down into pieces, let's just have a calculator do the algebra? Or do you think that's sort of not a promising direction?
Yeah, that's a quite good question. Yeah, so it's more like, the symbolic way will be more effective when dealing with especially the numerical reasoning part, like addition and subtraction and comparison between two numbers. Right. That's that's it. But we need annotations as well. Yeah. So for example, if we want to produce the answer of two number addition, we need to annotate the equations, right? We don't have that one. So here, what we want to achieve is using the language models and to finalize it as an end-to-end way, using the sub-questions to, implicitly incorporating the reasoning ability to the language model, like having the multi-hop reasoning abilities, inside the language models. Yeah. So the symbolic way is elegant. I need to admit it, but we need a lot of annotations for the equations and for the intermediate answers. Yeah, that's quite expensive to annotate. Yeah.
Other questions? Yes.
I saw a result. You use few shot on GPT-3.
Yeah.
I just wondering, how do you construct the prompts to give it to GPT-3 in this case? Like, you give it also like the sub questions in your prompts, or like just a question and answer?
Just a question and answer.
Do you think it's fair?
Sorry?
Do you think it's fair? Because like, what if you give the GPT-3, here are the sub questions you're gonna think about, and then here is the final answer I expect. And is there gonna be any change, like if you change the prompts, the way you construct the prompts?
The zero shot, it's like, we just give the complex question and context, right, to generate the answer. It's just like a baseline. It's just like a baseline model, right? And few shot is like we given the prompt like random selected, or not randomly selected, but based on the cosine matrix similarity to select some prompts or some context and the corresponding question and answer pairs to form the prompts. So I guess it's fair to compare with our model. But if you think that's not fair, we can add some sub questions and to see what happens in future work, maybe. Yeah. Thank you for your question.
Okay, so let's thank the speaker again.